Five continents connected by the passion of mathematics. Learn and explore with Anil Kumar.
Hi, Mata Savia. How are you doing?
Hi, sir. How are you?
Very good. Very good. Good to see you. That's great.
Nice to see you.
Yeah. Can you tell me about yourself?
Yeah, uh, my name is Matasavia. I'm from Ethiopia, which is located in eastern part of Africa, in Horn part especially. And I'm a grade 11 student. After 1 year, I joined the university, and I'm so happy by looking you here. And
Same here.
when I looked you the first time, I was searching some math problems in YouTube, and I looked you with Ami. Ami's, I think she's your student, and I was,
Amy.
yeah, exactly. And immediately I decided to have such kinds of conversation with you, and
Yes.
that
Yes.
is my pathway to have this class.
See, Mata Savia, let me share with you how global we all are. I come from Asia. I'm basically born in India, immigrated
Okay,
to Canada. So I'm now speaking to you from North America, another continent, right? So moved from Asia to
yeah,
North America. And then you're talking about Amy, who is my student from UK that represents Europe. And you are in Africa, right? So
exactly. Yeah.
we have covered all these continents. The only continent left today is New Zealand and Australia, correct? That part of the world. So what I'm going to do is you told me what you want to study. So I will share a video of my visit to New Zealand, and that's our love for the globe. And in this particular video, we are going to have all the five continents represented in this particular way. How do you like this idea?
Yeah, it's the best idea, and I'm so excited by looking you here.
You will be the
Different.
part of this, and you're the first person with whom I'm going to make a video which represents five continents. Does it make sense to you?
Thank you for the given
Yes.
chance.
Yes. Now tell me, what do you want to learn from me?
Yeah, I wanna to learn with you trigonometric function in today's class,
Yes. Okay.
especially the general how to we can find the general solution from the given equations.
Yeah. Mother Savia, you are a bright student. I saw into your credentials. Can you tell me about your credentials? What did you do in middle school? How was your performance?
Yeah, actually, I'm a good student, and I can show you my grade 8 ministry exam. We call it a ministry exam in grade 8, and our education curriculum is based on three levels. The first level is primary, and the second one is like a secondary school from 9th up to 12, and the third one is a university or a college, you know.
Correct.
And I can share you my
Sure. Sure.
eight.
Sure. Sure.
Okay.
Sure. That's good. Very good.
Yeah,
That's a certificate. Can you read out your marks?
yeah. My maths result is I think 95 from 100. I missed two questions, but I'm not sure which question is I missed it.
So I see that you got all the marks in 90s, which includes mathematics also, and 95% in mathematics. Great job. Correct. Here we have a couple of equations on this particular page. We will look into such examples. And so we will also, by that, learn what you want to know, correct?
Okay.
Okay. So the very first question here is like simple trigonometric ratio tan x equals to 0.5. And we need to find the solution between the interval 0 to 2 pi, for example. but you need general solution, correct? You need
Yeah.
general solution. And
Mm.
so we have different kinds of equations here. The first set of equations are linear equations, where we have like 3 minus 4 sine x minus pi by 3 equals to 0, correct? That's the kind of equation you also had, right?
Yes.
And, uh, and then we have quadratic type of equations in the second set. Question number 7 to 11 are all
Yeah.
quadratic in nature. So we need to convert these quadratic equations in one term, that is one trigonometric ratio, and then solve it in the fashion we solve the quadratic equations. That will give us the solution, correct? The third
Okay. Yeah.
set is very typical. We have a very complicated equation. Now, these equations need to be simplified using identities, and then we find a solution from these equations. You get the idea.
Okay.
So that is how the equations could be solved. So this is a wide variety which I'm going to share with you in today's video. Is it okay?
Okay. Yeah.
Fine. So let's go through the very first, very simple question to begin with, right? So
Okay.
I have two examples here. Let me uh, read out these examples. Okay. So first one is tan x equals to 0.5. So we have tan x equals to 0.5, right? I know on
Yeah.
the top, I've written that you need to give me a solution from 0 to 2 pi. Can you tell me, how do we find solution of this particular simple linear equation where we are just given one ratio and its value, which is 0.5 or half, correct?
Yeah.
So once you have this, you look into the coordinate plane as I've drawn on the side, and you know the rule, which we say cast rule, right? You are familiar with this? As far as tan is concerned, it is positive in quadrant 1 as all are positive and in quadrant 3. Now, since it is 0.5, we know that it will lie in quadrant 1 or in quadrant 3. When we are talking about 0 to 2 pi, right? So first I'm giving you a solution from 0 to 2 pi, then I will extend it to general solution here.
Okay.
Right. So there are two ways to go about. One, we go say what x is. We know x is equals to tan inverse of 0.5. This is one way of doing it, correct? We just find tan inverse of 0.5. You can use calculator, and when you use calculator, you have to use it in radian mode, right? So radian mode, because you need answer in radian mode, correct?
Yeah.
Use your calculator and tell me what is the value of x.
Okay.
Let me also do it and you also do it. Okay, so shift tan inverse and we need 0.5. What do we get? We get 0.4636. What do you get? You get the same thing?
Yeah.
Same thing, right? So the tan value, x value 0.4363, we use the calculator to find the tan inverse. The mode should be in radian, very important, correct? Because we're talking about 0 to 2 pi. So of course, we get one solution which is in quadrant 1, and let us say that this is kind of like this, right? So we got one acute angle here. So I say always, we have got the acute angle. I'll call this acute angle as alpha, right? So I'm saying the x value in our case is alpha, right? So for this, we know alpha is basically 0.4636, correct? So the
Yeah.
x value will be, we can round this to two decimal places and we can write this as 0.46, right? And the other
Yeah.
value is 180 plus pi, correct? So this is pi plus alpha, right? I should write pi plus alpha, right? So
Yeah.
this will be pi plus alpha. So I'm writing pi plus 0.4636, right? So if I add pi to this, what do I get?
Yeah, sir. I have a question here.
Yes,
Okay, and this why does you say pi plus alpha?
correct.
I think in second quadrant we subtract pi minus some angles. But
Yes,
why you add it?
yes, because we are looking for solution in quadrant 1 and in quadrant 3, correct?
Yeah.
So as you can see, the vertically opposite angle is also alpha, correct? So
Yeah,
this,
exactly.
if you look into this, straight line is, yeah, you're right, uh, pi minus alpha. You're right, you're right. So we basically wait. So pi, let me just erase this. Let me erase this and then show you. If you look
Okay.
into this is pi. Do you see this pi? And that is alpha, right?
Yeah,
So therefore,
exactly.
the total angle is how much?
One 180.
Pi plus alpha. You get the idea?
Yeah, exactly. Yeah.
You get the idea? So
Ah, yeah, I see.
you see that? So let me redraw it. Not a problem. We'll just redraw it. So we have this particular diagram and we figured out that the acute angle was alpha and that was equals to, let me write this as 0.46, right? Or let's say
Yeah,
alpha for now, right? So
mhm.
the other angle, this angle is also alpha, right?
Yeah, exactly.
Now, what is the total angle? The total angle is this angle, which is pi
Plus alpha.
plus alpha. Do you see that? So the
Yeah,
total
I
angle,
see.
let me draw like this. Another diagram like this is okay. So this is
Yeah, I see.
pi plus alpha. Now I think it is clear. Is that clear to you?
Yeah, I see. Yes.
So therefore, we get the x value as equal to alpha and pi plus alpha. Is that okay?
I see. Yes.
So when you calculate, you can calculate this and you get the, let me write down now, calculated value 0.46. I'm rounding it. And the other value was 3.61. And all are in radians, right? Now, radian, as you know, is a default unit. So even if you don't write, it is obvious that it is radian. But in the test, it is a good practice to write radians. Is that okay?
Okay.
So do you understand this particular concept? How we got this
Yeah.
answer, right?
Yeah.
Okay.
I see. Yes.
You get it? Okay. So
Yeah.
first part we have done, and we have written the answer in the domain 0 to 2 pi. Now, let us talk about general solution. You are interested in knowing what could be the general solution. Now, for general
Okay.
solution, what is the period of tan?
Period of time is 180.
Yes, we talk
Okay.
about radians, right? Period
Yeah.
is pi. And
Yeah.
therefore, after every pi, it is going to repeat. And therefore, the value of x will be in general equal to alpha plus pi n pi. Do you see that? Where
Yeah.
n
I see.
belongs to integers, right? It could be positive or negative. So that becomes a general solution, correct?
I
In
see.
our
Yes.
case, we found that the alpha value is 0.46. So we write 0.46 plus n
And
pi. Is this clear to you?
yeah, I see.
So that is how we get the general solution for a trigonometric ratio whose value is given to us. Is this part clear to you?
Yeah, I see.
Perfect. Okay.
Yeah.
Now
Yes.
let us take the next example. See, the way I'm taking you examples is every example is going to teach you a new thing. So let me now take the next example, which is cos 2x equals to 0.315. Okay.
Okay.
So I'm going to erase this and we'll now do the second example. So I'll post the recording, which you can watch later again to understand better, have better concepts. So we have now the question 0 cos 2x is equals to 0.315, right? So as you can
Yeah.
see, cos 2x, which we want, is positive, right? So let me write down this as cos theta, right? Okay. So we'll do two things. One, we'll also find solution between 0 to 2 pi. Is it okay? So we'll
Yeah.
first find the solution when x is between 0 to 2 pi. Now you see in the question, we have 2x. We do not have x, right? So I have to
Mhm.
multiply this by 2 and therefore we have to now look into a bigger domain which is from 0 to 4 pi. You get this idea here, correct?
Yeah, exactly. Why does we multiply by 2?
Because I wanted the answer to be in 0 to 2 pi. But my argument, this is what we call argument. is 2x, not x, 2x, twice x. So I have to
Yeah.
multiply this by 2. Everything gets multiplied by 2. So our domain now becomes from 0 to 4 pi for 2x. Is this clear to you?
Sure. I see. Yes.
I will show you in another way also. So when we talk about cos 2x, in that case, we have a function which is kind of going like this. This is your sinusoidal wave, right? When I
Yes.
say cos really means what? It starts with the maximum, right?
Yeah. Origin.
That is
Yes.
cosine, correct? Now, when we
Yeah.
say cos 2x, that means there are going to be two waves in 2 pi, one cycle, 2 pi. Do you understand?
Yeah. But why you? Why I see two symmetry line? Why
So,
does you? Yeah. Why
uh,
you add 2 pi and 2 pi symmetry line?
yes, 2x means there are two waves in 2 pi. In one period of 2 pi, there will be two waves. Each cycle. Now, period of when we have cos 2x, then one wave will be pi, correct? The
Yeah.
other wave will be, sorry, the one wave is not here. The wave ends at this, oh, sorry. Wait. Mhm. Okay, so pi will be here, right?
Yeah.
Got it. So one wave is in the period of pi, second wave again, because the time period for cos 2x is pi, right?
Mhm.
Cos 2x means, let's try to understand in another way. It means this. In the coordinate plane, we are going around one wave and then the second wave. Do you see this wave?
Yeah.
That is my cos 2x. That means in a circle, I will go twice cos 2x. The frequency is double.
Okay.
So
Yeah.
the time period is half. Instead of 2 pi, I have a time period of pi. Do you see that? Answer 2 pi. Now, when I say that cos 2x is 0.315, then it means I'm looking for solutions which are like this. Let me draw a horizontal line, which is y equals to 0.315. Is that okay? So
Yeah.
within this period, these are my solutions. Do you see my solutions now?
Yes.
How many do I have?
One,
Four
two, three.
solutions.
Yeah. Four.
So because my wave is crossing the horizontal line 0.315 at four different
So,
places as shown
so
here.
I have a question here. Sorry.
Yes, 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 yes.
Uh, why does we don't include in 2 pi and the origin, since the argument says that from 0 less or equals to x less or equals to 2 pi, but
Correct.
we don't include the origin in the 2 pi.
We are including. Our period starts from 0 to 2 pi, but the solution is where the line y, horizontal line y equals to 0.315 intersects the equation cos 2x, right? So cos 2x is this graph shown in blue. And it intersects at these 4 points. Do you see those four points? Within the domain 0 to 2 pi. You get the idea now?
Yeah, I see.
We got four solutions, correct? Four
Yeah.
solutions. Now, how do we figure this out? We say, well, let cos of alpha equals to 0.315. Is that okay? So what is
Yeah.
alpha equals to? Alpha is cos inverse
Using
of
verse.
0.315. Please tell me what is the answer?
Okay.
Tell me.
I think it is 71 degree.
No, you have to change it to radians. We are working in
Okay.
radians. Change the mode to radians and then tell me, please. That is very important.
Oh, oh. How do I can change it in mode?
Okay. Which calculator are you using? Show me your calculator, please.
Just
Is it something like this?
yeah,
Okay.
but
Very similar. So you will
yeah.
have a thing which is called mode. written, so you do shift and setup. You say shift and mode. And within the mode, for my calculator, it gives me 4 for radians. And then I
Okay.
use, do you have that mode there?
Yeah, I had in my phone for mode.
Mode. Now, mode
Yeah.
should be in radians, not degrees. Change it to radians. Have you changed?
First I shift and then I mode.
Yeah. Then they will give you some numbers 1, 2, 3, 4, 5, 6. Check. Where do you have mode written? Radian. Where is radian written? In your calculator. Radian is which number? For my calculator, it is 4. I don't know in which number is yours.
Yeah,
Radian.
but I don't know how to I don't know how to
Okay. So for now, what you do is next time when you go to school, take your calculator or read the instructions on the calculator to figure out how do you convert that to radian from degrees, right? Change mode,
yeah.
right? So you do change mode to radians, right? So I'm writing down here, right? So let me write down in red for you. Change mode to radian measurement. Is it okay?
Yeah.
Now, when you do that in my calculator, when I do it, so as a shift cos inverse of 0.315, I get 1.25.
Okay.
So we are going to use this angle 1.25, not 71 degrees. Is that okay? Because you are working in radians, right?
Yeah.
Yes. Now we know that the acute angle is 1.25, right? So let us say this is my acute angle alpha. So within 0 to 2 pi, basically, I have to now, I got this one value, right? Now, the other place where cos is positive is where? Cos is positive, we know the cos rule, right?
In first and in fourth quadrant.
So that is the other angle, right?
Yes.
Fourth angle. So one is this. What is the other angle? Well, the other angle is 2 pi minus 1.25, right?
Yes.
So the other angle is 2 pi minus 1.25. Is that clear to you?
Yes.
So let me do. So 1.25 is first acute angle. The second one will be 2 times pi minus 1.25. And that gives me 5.03.
Yeah.
So I have two angles which are, I'm saying x, not x. Alpha, I'm saying 2x now because this argument was 2x, right? So the first
Yeah.
one is 1.25. The second one is 5.03. How did I get 5.03? I added 2 pi to 1.25, right?
Yes.
So this point is what we will try to find later, okay? Now, the circle repeats. So we have to add 2 pi again because we have to now work out within 0 to 4 pi, right?
Yeah.
We're checking 2x value, not x, 2x value. So when you add pi to this, again 2 pi to this, what do you get? So let's add 2 pi to this plus 2 times pi. It becomes 11.36. That is for this one. And 1.25 plus 2 pi, 7.53. So the value of 2x is these four values. So these are, so what is the value of x? We have to divide all of them by 2, right?
Yeah.
1.25 divided by 2, 5.03 divided by 2, 7.53 divided by 2, and 11.36 divided by 2. Is that okay?
Yeah.
Calculate
But
the answers.
from where that we get these solutions? The
Pardon?
four solutions. So I see the 1.25 is, but how does it get the four solutions?
Okay, I'll explain you more. Okay,
Okay.
let's go for a bigger shot here now. So we got first answer, which is right here. And we are saying this angle is alpha. Let me just write alpha, right? And
Yeah,
we are saying alpha is equals to 1.25. Is this clear to you?
yeah, yes,
Now, we are looking into cos 2x, correct?
yeah.
That is the function we are looking into. Now, cosine, as we know, is positive in which quadrants?
In first and then the fourth.
First and fourth. So
Yeah,
therefore, the other solution should be right there, correct?
yeah,
So those are my two solutions. So first two solutions. So when I go like this, look here, when I go like this, I get alpha. So I'm
mhm.
saying 2x is equal to alpha. And then I go like this. Do you see this?
Yes, I
So
see.
that is alpha less than 2 pi. So I could write this as 2 pi minus alpha, right?
Yeah,
Now the third solution will be 2 pi plus alpha. Do you see that?
yeah, I see. Yes,
And the fourth solution is, let me start like this. Okay, let me go like this. One full circle like this, and then coming back here, right?
yeah,
Do you get the idea? 4 pi
yeah,
minus alpha. Two circles, but less alpha. You see that? So we get these four solutions. Now
mhm.
the idea is we actually want what the x is, right? So the x value is, we'll divide them all by 2. So it is
Yeah,
alpha divided by 2. Second
yes,
value is 2 pi minus alpha divided by 2. Then we have 2 pi plus alpha divided by 2. And then we have 4 pi minus alpha divided by 2. Is this clear to you?
yes,
Using your calculator, you can find all these values for x, correct?
yeah,
So we get these four answers. Do you see one answer, two answer, three answer, and the fourth answer, right? Do you understand now?
yeah,
And these answers are between the interval for x 0 to 2 pi. Is that clear to you?
yes.
Now the question is, how will you give the general solution? So let's now look into general solution, right?
Yeah,
So general solution, we saw that the alpha value repeats after 2 pi, right? So we
yeah,
have x equals to alpha plus 2n pi, correct? Because
yeah,
it repeats. Also, we found that the other answer, which was 2 pi minus alpha, also repeats after 2 pi. So the
yeah,
other solution is 2 pi minus alpha, right?
yeah,
Plus 2n pi.
yeah.
Is that clear
I,
to you?
yes, I see.
So this is the solution, correct? But now you let us realize one thing. In this particular case, alternate solution. Let me give you alternate easy solution. Again, I'll show you. It will be very clear to you.
Okay.
So when we are drawing this answer for alpha, we found that one answer is this, right? The other answer is right there, correct?
Yeah,
So one is alpha, the other one is minus alpha, right?
yeah,
So general solution, I could also write like this. That our 2x, because we are working in cos 2x, remember the question cos 2x is
yeah,
equal to plus or minus alpha, and because it repeats after 2 and pi, plus 2 and pi. Do you see that? Where n belongs to integers. So we could write plus and minus alpha plus 2 and pi. You get the idea?
yeah.
So
I
for a
see.
cosine function, because it repeats after 2 pi, and
Yes,
even if you simplify the last version, it will give you minus alpha plus 2 and pi. You get the idea?
yes,
So that is what our solution now is. So for the equation which we had as cos 2x equals to 0.35, so let me write down. So the equation is cos 2x equals to 0.315. the general solution is this, correct?
Yeah.
Are these steps clear to you? Does make sense?
Yeah, it's nice.
Okay. So one question for you now. Okay.
Okay.
So we'll have this question, and let us work in degrees. We'll work in degrees. Okay, don't worry, because you have calculated in degrees. We'll work in degrees. My question is, sine of x by 2 is equal to, let us say, square root 3 over 2. Correct?
Yeah.
Find general solution.
Okay.
Tell me, how will you do it?
First, we looked where is the sign value positives.
Correct?
Yeah, we looked in the first and in the second quadrant.
Correct?
Yeah, and I think
Find the acute angle. So find related acute angle.
yeah, the acute angle is I think 60 degree.
Yes, it is a special triangle, right? So
Mm.
it is a special triangle which I have taken for you, which you can draw here. And it is 30, 60, 90 triangle, which gives you the values, which are 1, 2, square root 3, right?
Yeah.
And so this is 60 degrees we are talking about, right?
Yes.
So yes, the related acute angle is equal to 60 degrees for us. Perfect. So we know that alpha is equal to 60 degrees, correct? Now,
Yeah.
what is the other value when it is positive? Can you tell me this value?
I think it is 180.
Yeah, 60 minus
180
60 minus
degree.
180, the 120 degrees. Is that clear to you?
Yes, I see.
So this is 180 degrees minus 60 degrees, which is 120 degrees, correct? So those
Yes.
are the two angles which we are looking into as a solution of uh, alpha, right? But in this case, the angle is x by 2. We are talking about sine x by 2, right? And therefore, we'll now write x by 2 equals to 60 degrees and 120 degrees, correct?
Yeah.
So what is x equals to? X is equals to 2 times
Surprised.
60 and 2
Yeah.
times 120, correct? Which
Yeah.
is 120 degrees and 240 degrees, correct?
Yeah.
So we get the solution, and now we can write the general solution. And so what is the general solution?
Uh, two,
X equals
two,
to, we could
two
write
in the
like this,
past.
120 plus 360n
Yes, and
and
240 degree.
plus 360n,
Yeah.
where n belongs to integer. Is this part clear to you?
Yes.
Correct? So that
Yeah.
is how we could actually solve a simple trigonometric uh, ratio type of an equation, a linear equation. But here, see, the phase shift, that time period was changed. You see that? And that changed the whole thing. So we learned today, how do we solve trigonometric equation where the period or the periodicity of the function is changing, right? Sine half x means that in one wave there will be, in 2 pi there will be only half the wave, right?
Mhm. Yes.
So this is 2 pi for us. When we are talking about sine x by 2, right?
Yeah.
Only half the wave. And therefore, when we were looking into the solution, we have only two solutions which are as shown here. You get the idea.
Yeah.
So that is how we actually work these things out, right? Because one full wave will be 4 pi, correct?
Yeah.
Right. So that is how, well, we are talking about degrees. So I should have written 180, this 360 degrees, right? And that will be 720 degrees. So in first 360 degrees, we have two solutions, 120 and 240. And thereafter, it keeps repeating, right? General
Yeah.
solution also means that it repeats on the negative side also. Therefore, we take integers, which are both positive and negative. Is this part clear to you for today?
Yeah.
Perfect. So today, I think we will only understand how do we solve these types of equations, which are
linear.
linear, where the frequency or the k value or the time period is changing? Is that okay?
Yeah,
So these are transformed. Either they are compressed or expanded, correct? Which we took today, right? And we also
yeah,
looked into general solution. Is it okay?
yeah,
Correct. So with this, I think you have learned a part of trigonometry, correct?
yeah,
Can you summarize? If you are trying to solve a trigonometric equation which is linear in form, where the time period is different, how will you find the solution? Yes. I'll close
yeah,
this. I'll stop sharing. You explain me. I want you to visualize and then explain. Yes, if I have sine 2x equals to half, how will you solve this equation? Tell me.
yeah. First of all, we looked the given radians, and then we identify the quadrants.
Quadrants. Yes.
Yeah. Then we will transform by
Yes.
looking. Yeah.
And
And
then you find,
then
yes, related acute angle.
yeah, and we looked when the given angles is like positive, or by looking is the main thing is like we focused on quadrants,
Yes. Yes.
and in which angle is it's positive or negative. And
Yes. Then we
yeah,
find general solution. Time period being 2 pi. We had 2n pi, right? Where n is an integer. It could be plus or minus. And so we gave you a general solution. Correct. We also
yeah,
looked into how do we find within a given domain of 0 to 2 pi. So we
yeah,
actually understood a lot about it.
beautiful.
So see, do you see this volcano? This volcano is very regular. It is periodic, just as we have periodic trigonometric functions, correct? It is
Yeah,
called Lady Knox Gyrox. So it's a geyser. So this geyser is extremely periodic, and we know exactly when will this geyser erupt. So just as sinusoidal functions are periodic in nature, this geyser is also periodic in nature. And so it very much relates to our lesson on trigonometry. Does it make sense to you?
yeah, it's very
So in that
interesting.
way, we have covered the continent of Australia and New Zealand. You see that? So now it completes the five continents for us. Does it make
Oh,
sense?
yeah, that's great and impressive.
So next time you have to share with me the wildlife of Zambia. So we'll see a part of Africa also in that fashion. Correct?
Okay. Yeah,
It's a very beautiful thing. And this is like uh, such a good tourist attraction.
yes.
So you can model the eruption of volcano using trigonometric functions since it is periodic in nature, correct?
Yeah,
So that is where we are going to end today's class. Okay?
yeah,
Okay,
yeah.
great.
Okay.
See you next week. See you next time. We'll work out a time. Okay? Great.
See you too.
Thank you.
I love
Bye.
you so much. Bye.